Today we'll learn how to find the number of valence electrons for any element. Valence electrons are the electrons in the outermost shell of an atom that can participate in chemical bonding. There are two main methods to find valence electrons. Method 1 uses the periodic table group number. Method 2 uses electron configuration. Let's explore both. Let's start with method 1. Here's a simplified periodic table showing the main groups. The group number for the main group elements, that's groups 1, 2, and 13 through 18, directly tells us the number of valence electrons. Let's look at some examples. Take sodium Na in group 1. It has 1 valence electron. Magnesium Mg in group 2 has 2 valence electrons. And chlorine Cl in group 17 has 7 valence electrons. Now let's look at method 2, using electron configuration. Electrons are arranged in shells around the nucleus labeled K, L, M, N, and so on. Each shell contains subshells, S, P, D, and F. To find valence electrons using electron configuration, first write out the electron configuration. Then identify the outermost S and P subshells. Count the electrons in these subshells. Let's do an example with chlorine. Chlorine's electron configuration is 1 S2, 2 S2, 2p6, 3 S2, 3p5. The outermost subshells are 3s and 3p. There are 2 electrons in 3s and 5 electrons in 3p, giving us 7 valence electrons total. Here's a quick tip. For main group elements, both methods will give you the same answer. The group number method is usually faster, but understanding electron configuration helps you understand why elements in the same group have similar chemical properties. In summary, you can find valence electrons either by looking at the group number for main group elements or by counting electrons in the outermost S and P subshells using electron configuration. Both methods are valuable tools in chemistry